Hello class, and welcome to the Chapter 4 of the ER book Illuminate session. Now this chapter, I'll preface it, this is a lot of material to cover. It is a very important chapter. However, it's really not that bad. All we're doing is giving you a lot of rules and asking you to apply them. We're not really too heavy into the theory yet. So really it's just what to do. And as long as you have the book handy, as long as you can remember these rules, this is pretty easy to apply. We'll go over the concepts, and you should just take the rules as they are, apply them, and we're not worried about the reasoning behind it yet too much. Okay? So I guess we'll go ahead and begin. Now this is extending relationships and structural constraints, and it's about time because last week we covered beyond the first entity, beyond the actual first entity. So we covered more than one. And now it makes sense that we'll view the relationships that link those in detail because we have to relate them or else they wouldn't be in the same ER diagram. Okay? Today we're going to go over structural constraints, and those are, like it says, constraints. They're restrictions, and they come in two flavors: cardinality and participation. Cardinality is number. Participation is whether or not they have to participate in the relationship. It's also called optionality sometimes. We will extend our grammar. As I said, we'll be extending this English grammar throughout the length of the class. It'll grow lengthier and more refined, and we'll keep working on that. So don't be surprised. Each week each ER week anyways, there will be a little bit more on this. Okay, we'll extend it a little bit more, and we will go ahead and give you a few more mapping rules. Okay, now structural constraints are how they are related to one another, two or more entities. And as I said, we have cardinality and participation. And cardinality is the number, okay? So to measure the number of entities that will be related to another entity. So it's your ratio, X to X, ratio, cardinality ratio. So you have four types: 1 to 1, M to 1, 1 to M, and M to N. And this is where M and N are just any old variables. Remember from algebra and beyond, and even pre-algebra, M and N can represent any number. In our case, they're whole number integers, okay? And you see these two are the same. The 1 to M and M to 1 are actually the same. They're just reversed. We just kind of do that from a friendliness standpoint. 1 to 1 is pretty straightforward. That's when one entity is only related to one occurrence of the other, okay? Many to 1 is where many occurrences of an entity or many instantiation, many objects are related to one other entity. 1 to many is where one instance of an object can be related to many of another, and then also many to many. Let's say 20 of one type of object can be related to 50 of another, or 3 and 8, where M and N are any whole numbers, okay? Greater than 0. Greater than 1, I guess I should say, can be greater than 1. So 1 to 1. So this is where only one instance of an entity is related to an instance of another entity. Okay? Written as, one side to one side. So here we have a 1-to-1 relationship between employee and parking space. And here's the English that makes sense of it. One employee parks in a parking space, and one parking space is parked in by one employee. One parking space per employee. An employee only has one parking space. Okay, so makes sense. Here it is as an ER diagram. An employee parks in a parking space. A parking space is parked in by an employee. And you can even get more specific and say one employee instead of an employee. It makes maybe a little more sense that way, I guess. And we're not going to get to it yet, but these are your relationship. This is your optionality. It is partial participation on both sides. So one employee can park in one and only one parking space. One parking space is parked in by one and only one employee. Okay? So that's the relationship said both ways. Many to 1. Well, guess what? Surprise, surprise. 1 or more to only 1. Okay? 1 or more related to one other entity. Written as, let's say, employee supervisor, M1. So you have many employees to one supervisor, which makes sense because, you know, that's the whole point of a hierarchy. You don't have to have everybody managing everybody. You know, you have many go into one. Employees are managed by one supervisor, and one supervisor manages many employees. Or actually, I prefer the active than the passive, but it doesn't matter which way you say it, really. And here we'll have an example. There we go. Many employees, one or more, can be managed by only one supervisor. One supervisor can manage one or more employees. Okay? Notice we have the partial participation. So, can. M and one. So many employees to one supervisor to many employees. And this is just the same thing the other way around. One to many. Same thing. Same thing. It just depends on what way we orient it, what way we're viewing it from. You know, one to many is really the same as many to one, just kind of flipped around. You know, if it's a different ratio, sure, but if you just flip two objects around, then hey, you're also flipping around the ratio. Okay. One entity is related to many, one or more employees. That's pretty intuitive to us. So there you go. Same thing. Employee independent. So in this case, one employee can be related to one or more dependents. So there we go. One employee, notice the one here, is related to many dependents, and a dependent is related to one employee. So an employee can have more than one, and dependents only have one employee that they're related to. And here's an example. One employee can be related to one or more dependents, and each dependent or dependents are related to one and only one employee. Okay? M and 1. And we have many to many. So guess what? Many occurrences of one entity are related to many occurrences of another entity. And, you know, as we said before, many are just, it means one or more. So here you go. Employee project is an example, M to N. An employee is related to many projects, and a project is related to many employees. Sorry, here's the example here. Employees or an employee works on one or more projects. Projects are worked on by one or more employees. So you have a many to many there, okay? Now, you know, there's more than one way to skin a cat. One is not necessarily the only way to do it. You just want to select the best way. Given your situation, your business constraints, etc., you want to pick the best way to model these and not try to account for every single situation, because that's not correct either, okay? You can have possibly more than one ratio, okay? And that's kind of a clue that you'll actually have. You know, you'll look at M. If you say, well, I could possibly have more than one in this case, you might want to make it M, okay? And that way you'll be covered, meaning multiple instead of one on one particular side. If you have a question, you know, about, well, there could be more than one of any particular whatever entity. Okay. So you want to build it based on the current situation, which, you know, as I said, it depends on what it warrants, and not on any possible situation, because you can't do that. Okay. So don't fret too much about these. What it's trying to say is go with what seems most correct. Okay. Use your intuition and logic. And you also get the chance to explain it in your English grammar as to why you chose that. Okay, so now we're at participation. Now, if the cardinality dealt with numbers, you know, your whole number ratios, how many goes to how many, what, you know, whether it's one or more. And participation is your optionality on a relationship. It's whether or not a particular entity has to participate in a relationship. Okay? And there are two types. There's full and partial, and they're also called mandatory optional. Now, with full participation, guess what? That entity must participate in the relationship. I bet you already knew that before I even said it. Okay? Must shows full participation. Okay, makes sense. Now it's depicted by a double line on the diagram, and you'll see here ahead in the slide ahead they didn't exactly show it as a double line, but it is a double line. If you go back and read the or watch the ER tutorial, or if you even read the written tutorial and do it, you'll see that it's indeed a double line. Or if you read the book, you're supposed to be reading the book. I hope you are. Okay. Then you have partial participation, also known as optional. And that's where an entity may or may not participate in the relationship. Okay? And it's a single line that connects the two. So if we go back up here, what do we have? Employee parking space. There's a one-to-one, and it is partial on both sides. An employee may park in one and only one parking space. A parking space may be parked in by one and only one employee. Okay? Same here with employee supervisor. Employees may be managed by one and only one supervisor. A supervisor may manage one or more employees. And notice it's, like I said, it's not exactly a double line. This is not my ER diagram, or I would have done it that way. This is not my PowerPoint, I guess I should say. But, you know, they're thickening the line to simulate a double line. So here's your partial and here's your full. Now, in this scenario, you've got one employee may be related to one or more dependents. Dependents must be related to one and only one employee. Must. And I said dependents plural because we see it's M, and I said one employee because we see it's one. So there we have it. There is our optionality, and there's our cardinality. And here's our relationship. And it echoes what I said. May be related to one or more dependents. I don't say zero or more because may implies they could or could not. So it implies zero to me. And each dependent must be related to one and only one employee. If we go back, that makes sense. Okay, employees may be related to one or more dependents, and dependents must be related to one and only one employee. So we kind of got a recap of our methodology, and we're adding to it just a tiny bit here. So we'll select our primary entity, strong entity. We'll show the attributes on it. Okay. We'll give it a key. Show data. We'll use our structured English to go ahead and describe. Then what we'll do is we'll go back and see if there are any attributes we need to turn into entities. Remember, you can't have attributes with other attributes on them. If that's the case, you need to turn that thing into an entity. And here you go. If an attribute or attributes are entities, you need to convert them into an entity. Excise them and convert them into an entity and repeat the process with that new entity. Okay? Then you create a relationship between the new and the old. You keep going. You do that iteratively. And you do, do this as needed. Okay. Now, go ahead and include your structural constraints, cardinality and participation. So you draw your single lines or double lines as necessary. Put your cardinality numbers on there. Then we go ahead and state the relationship back and forth, give all of our data to the user, along with sample data, and elicit feedback. So that's our new methodology. Pretty easy. We just keep adding to it a little bit each time. That's all. Okay, so now we're going to throw a few new mapping rules on you in this chapter, but this isn't too bad. Remember, you can always refer back to them. It's best to memorize, and they will make sense as you start building your tables and you see why it works out the way it does, why they turn into a normalized table. So when you have M to N, you have to create a new table and just go ahead and make the new table the combination of the primary keys of both of the entities. Now you're going to put the table is going to consist of the primary keys of both, and the primary key of the table is going to consist of these two attributes of both primary keys concatenated. Okay? So that's what you do with an M to N. So here's an example of an M to N. We have employee and project. Employees may work on one or more projects, and a project may be worked on by one or more employees. Okay, notice our key for employee is EmpID, key for project is project ID. Okay, so since it's an M to N, come mapping time, project manager and project ID are going to be in my project table, right? EmpID and name are going to be in my employee table. And according to M3A, I'm also going to have another table that relates employee and project. I'd probably call it employee underscore project. And the key of it, and the only entities, the only attributes in it will be project ID and EmpID, since that is the concatenation. That's the two keys. So let's see. Yep. Project ID and project manager, EmpID and name, those are both of the attributes on project and both of the attributes on employee, respectively. Then we have our table that relates these two, EmpID and project ID. Now that, since we have multiple on both sides, what that does is eliminate redundant rows, repeating groups, like we saw a little bit earlier. Okay, that eliminates those repeating groups and keeps this table normalized. So if we follow these rules, it's pretty easy. We can get database normalization done without any mental sweat. This works out that way for us. We draw it, we follow the rules blindly, and voila, we have a normalized database. So there you go. There's our new table, EmpID and project ID. So that's how we relate the two. And really, these probably should be underlined. I always like to show primary keys as being underlined. That way I know. M3B. Now when you have one-to-one, it depends. So you include the primary key of one of the entities into the table of the other entities as a foreign key. Okay, so we'll take the PK of one of them, stick it into the table of the other, and call it an FK, a foreign key, to relate to that entity. Now, I said it depends because, you know, which is entity A, which is the one that is referenced, and which is entity B, the one that has the reference in it. So here you go. Part 1 says if one side has full and the other side has partial, you store the primary key of the partial into the full. So the table, the entity that has the full participation, that table is going to receive the primary key of the entity that has partial participation in it. And we'll see that in a sec. We'll give you an example. So here we go. We've got employee and computer. Notice they're both one-to-one. An employee can use one and only one computer. A computer must be used by one and only one employee. Okay? So we have a full and a partial. Now since computer is full, it gets that foreign key reference in it, right? So what we do is we take this EmpID and we go ahead and throw it in the computer table. All right. There it is. That's a foreign key. You know, if I wanted to, I like to dash underline foreign keys, but since I don't, let's see. Yeah, I'm sure it can be done, but I don't want to bother with it right now. So I'll just in parentheses say FK so that I know it's a foreign key. Okay. So what this does, this emp ID references this employee table. So that way I can pretty much, if you look at it logically, I can store all of my employee ID information in this computer table just by having an emp ID. That way I don't have to update the name. I don't have all these insert, update, delete anomalies because I'm logically storing information in here because I can always use this to jump to this table to retrieve the employee information, but I don't have the excess repeating groups there. So it maintains normalization. All right. So there it is, and that's just a different view of it. Now go ahead and underline barcode because I like to underline the I like to underline the primary keys for good order. There we go. Okay. So now part 2 says if both sides are partial, you can just say, hey, it doesn't matter. I'll go ahead and choose eeny, meeny, miny, mo. All right? You can choose either one to store the primary key of the other. It's not really a good policy there because we will have some null values. Okay? What you can do instead, and what I'd like you to do, is to go ahead and treat it as for M to N. You just create a whole new table with the 2 keys in it. Okay? So here's partial to partial. An employee may use one and only one computer. A computer may be used by one and only one employee. Okay? So what we could do is we could stick emp ID in computer here, or I could stick barcode in employee, or, and my preferred method, I could just create a new table that says, you know, something like it's called computer underscore employee and holds both of these values. And they're both part of the PK. So there you go. There's alternative 1. Store emp ID in here. We will have to have some null values if we do that. Because employee doesn't have to participate. All right, here it is just from another view. Or we can create a whole new table. This is much better. There we go. With the employee ID and the barcode right there, or an employee and the computer via the employee ID and the barcode, respectively. Okay, whole new table that relates these two. No redundancy here either. And here's the data of the new table. And just to show you that they're both part of the primary key. There we go. And now if we have a one-to-one with full, it doesn't matter. You know, we won't have null values, and we can just go ahead and stick a primary key of one of them into eeny, meeny, miny, mo, the other one. Okay, if we have a one-to-one relationship with full participation on both sides, like we do here, I have one-to-one. An employee must use one and only one computer. A computer must be used by one and only one employee. So again, I'll make an intermediate table, and it will consist of barcode and emp ID, and they'll both be part of the primary key. Oh, excuse me. I'm sorry. I'm thinking of one-to-one partial. It will make a we'll go ahead and insert the partial key into one of the other entity tables as a foreign key, and it doesn't matter which. So I'll either end up with computer, barcode, manufacturer, and a foreign key that is emp ID, or my employee ID will end up with the attributes emp ID, name, and then a foreign key of barcode to relate the employee to the computer. And they went ahead and created an employee table with that foreign key. That's how they did it. They stuck barcode into employee. And there we go. So there's our employee table. You know, we put employee ID, or we put barcode into it as a foreign key. But again, since it was a one-to-one, full participation, we could also have done computer and stuck employee ID into it as a foreign key. We can't do both, but we can do one or the other. And last but not least, 1 to M. And this also depends. Now, if you have a 1 to M relationship, remember 1 to 1 or more, and the M side is full, okay, you put the key from the single side and the M side as the FK, as the foreign key to reference that single side, okay? Or, if the M side is partial, then you have to create a new intermediary table. So here's an example. 1 to M supervisor employee. Employees must, actually that should be supervised by a supervisor, or a supervisor must supervise 1 or more employees. Okay, so this is full to full, 1 to 1. Okay, the M side is full, so what do? There we go. We put the single side as the foreign key on the plural side, on the M side. Okay? And there it is. So since employee is M, supervisor is 1, M side is full, so we take the single side, which is supervisor, and go ahead and put it in the employee table. That's a foreign key reference to the 1 side, the supervisor side. Now here's the other way around. Here's partial. Let's say my employee is partial. Then what do? That's when we create the intermediary table here. That way we stay with no redundancy. We won't have any nulls. And there's our new table. Consists of the primary key of both. Now these rules may seem a little awkward, and it's a little repetitive. Basically, I'm just reading what's off of the PowerPoint here, but since we don't want to get too deep into normalization right now, we simply apply these rules. We know that this will eliminate redundancy. We know that this will help us maintain a normalized database, and most importantly, we know that this is what we do to get 100% on the assignments. We simply apply these rules, and the power of the ER mapping tool is really, the whole ER tool in general, is that we can draw. It helps us mentally separate these things. We just go ahead and draw, and we separate them out, we have fun, and then we go ahead and transform these with simple rules. And really with little effort, we've created a normalized database from nothing. So this is the power of the ER tool. It's very easy, and it's fairly intuitive once you get to use it. Okay? So we've gone over structural constraints. Cardinality, just remember, that is your number ratio. Participation, remember that is whether or not a certain entity participates in a relationship. You know, whether it's optional or whether it's mandatory, whether it does or may participate. We've developed our English a little bit. We've given these additional steps here. And we've expanded on our database mapping rules to include the M3 series. Okay? Any questions, email, or please the discussion board. Otherwise, get to work on this and have fun, and I'll see you at the next lecture.